Today we're going to be doing the pendulum experiment. A pendulum is a weight suspended from a pivot so that it can swing freely. Pendulums have been around for thousands of years. The ancient Chinese used the pendulum principle to help predict earthquakes. Galileo was the first European to really study pendulums, and he discovered that their regularity could be used for keeping time, leading to the first clocks. Now, in the pendulum experiment, there are 4 important variables. One is length, in this case, the length of our string from one end to the other. The mass of the bob, which is the total matter of the pendulum. The force of gravity, which pulls the bob down as it swings. And lastly, a pivot from which the pendulum can swing freely. The materials that will be required for this experiment are a string, a paper clip, and a penny. The first step is taking your string and tying it to one end of the paper clip. Okay, and once you have your string tied to one end of the paper clip, you will insert the penny onto the other end of the paper clip, just like that. So as you can see, if I hold our string with our paper clip and the penny, it'll swing freely from side to side. The swinging motion is the pendulum oscillation. Movement back and forth at a regular speed is one oscillation. So I will go ahead and demonstrate. One oscillation would be 1. So when it falls and goes back to its original point. In this experiment, the length of our pendulum is 30 centimeters. I will go ahead and have my assistant set the timer for 10 seconds, and in that time, I will go ahead and count the amount of oscillations that my pendulum does. So when she starts the timer, I will start. 1, 2, 3, 4, 5, 6, 7. Okay, so it was 7 oscillations. Now, what if these variables were changed? If one of these variables changed, then the results would change. Let me go ahead and show you the results that I got from conducting the experiment previously. I recorded my data in a data table in which I recorded the 5 lengths in centimeters of the pendulums that I used, as well as the 3 trials that I did that I conducted for each length, as well as the average of the time of the trials. Next, I'll show you my number line, which you can see from this data chart that the longer the length, so this was my longest at 55 centimeters, the longer the length, the fewer the oscillations. Therefore, the shorter the length, that had more oscillations. This is a great example of how to integrate science and math by performing an experiment by making calculations such as averages to determine the results and then graphing them onto a number line. I hope you enjoyed this experiment. Thank you.